All right, let's do projectile motion. This is not the hardest one that's coming up. So let's stick it at 50 meters per second because I have no imagination right now. 30 meters, there we go. It's a variety. Let's put this an angle of
30.
30. I have 30 right here. I don't want to use the same number.
20.
37 degrees.
Okay.
So we'll get the 3, 4, 5 triangle going. And this time, oh, wait a second. I'm gonna take that 30 away because that's what we're gonna try to find. I'm gonna give this distance, we'll make that 30 meters. And the question is, how tall is the cliff? Frankly, I feel this one's a little bit easier than the one we did yesterday. So sort of lull you with that false sense of ease before I hit you with the next one. The process we go through is the exact same as we did before. So we get down the 5 quantities. We'll set up our positive directions. I am going to force to the right as positive. Sure, why not I hat? Up or down positive?
Positive.
Up.
Yeah, positive.
All right. So we got my I hat and the J hat. All right, so what do we know?
We know the distance, the like horizontal distance, that's 30, that's your is it distance? Yeah.
All right. 1.
The acceleration. 50 ms. 50 ms.
Ooh, you said acceleration, right? No, that's not the acceleration. We do know acceleration for this.
This is on Earth.
Yes.
It's 9.8, and it would be, we set up as positive, right?
Yes.
So it's negative 9.8.
Where?
And acceleration under the I hat. Oh, yeah, sorry.
I's, J's.
It's-
Like a missed
yeah.
one. So negative 9.8 meters per second squared.
And 0.
0 would be.
Yes. That's where I thought you were going, Dan. All right.
Velocity, the
Yep.
initial velocity,
Okay, what is the initial velocity?
the 50 ms.
All right. I'm going to nitpick that. Spirit, yes, that is an initial. What is that? That's 50 meters per second is not my initial velocity. What is 50 meters per second?
It's a combination of your two velocities.
Okay, we could go that route.
That's your, it's not your angle, but it's like the speed, and then you have your
Yeah,
angle.
it's the initial speed. But with the angle, we do have to take into account the angle with the velocity, so we get the components. And that is a key thing in doing this, is that you need to break it up into the parts. So I have 50 meters per second, 37 degrees, and I need to figure out how much is in the I hat, how much is in the J hat. Somewhere I'm going to have a marker that works really well. So on a calculator, 50 sine 37 degrees, which is about 30 meters per second, and 50 cosine of 37 degrees, which is about 40 meters per second. If I ever give a really long angle, if I did 36.68, you know, I've done it before where I've taken it out to 8 decimal places. And if I ever do that, it's because that will come out with nice values for the angle, or nice values for the components. And so initial velocity in the vertical or horizontal direction, 40 meters per second, and then over here, 30 meters per second. And what is going to bind my I hat and J hat columns? What is the same for both?
Time,
Yep.
and we don't know time yet.
But we have enough to find it. So which peak formula?
Displacement equals initial velocity times time plus half time acceleration at time squared.
Okay.
The only one I seem to be able to remember.
And therefore, well, that drops out. Because we're putting in the horizontal stuff, please don't mix horizontal, vertical, and angled. We're putting in just horizontal stuff into this equation, so I'm only bringing in these numbers over here. So I have 30 is equal to 40 times time.
Seems awfully fast.
Pardon?
Like the part of me that's assessing whether that's logical says that seems very fast. But I guess it's very.
Well, you're throwing something with a, I mean, you're throwing this thing with a vertical component of 40 meters per second, and it only goes 30 meters out, so it's not going particularly far. Yeah, I made that just way short. All right, so questions about this part? Oh, Ben.
Why didn't you put the 9.8 for acceleration?
One of the reasons why we break it into components is that they're very independent of each other than time. And so when you're plugging into an equation here, you're plugging in this stuff or you're plugging in that. You don't mix and match. And so because I put in 30 and 40, I'm gonna be using 0. Actually, as long as, if I use this one, I'm gonna be saying I'm committing to doing just the horizontal piece. We're about to use this, but when you're plugging into an equation, please make sure you're putting in related parts, so either the horizontals or the verticals.
What's the thing we're trying to find? It's the height, right?
Yes. Be this. Right, the absolute value of that. So now, well, we plug into that equation, except now with vertical stuff. Because Dan wants us to use 9.8, finally we're gonna use 9.8. So I have delta S, which is what we're trying to find, is equal to 30 times 0.75 plus 1/2 negative 9.8 times 0.75 squared. So there's no quadratic involved here, or no quadratic formula involved here. This is a simpler problem than what we did yesterday.
I got 19.74.
1974,
Yeah,
I assume there's a decimal point in there,
there is.
19.74.
Yes, I'm sorry. Meters. I do believe I said those pieces, and maybe you didn't say that.
I do not doubt it.
It is worth doubting.
I'd like to think I was thinking incredibly deep thoughts at that moment and missed it.
What did she get? Oh yeah, that's what I got too.
And so now, all of us are just a little bit better as people, now that we have our answer. Actually, there is something off here. You got 19.74, or you did something to get 19.74?
I typed in exactly what you have on the board.
Yeah, because 30 times 3/4 is 22.5, and then you add the second half, which is negative 2.75625, and then that gives you 19.74.
It should be
There's something
negative.
off here.
Is that what you're saying? It should be negative.
It should be negative, yeah,
Yeah.
but you got a positive.
I did. Let me type it again.
Yeah, so, which means I must have given too much information.
Why
Is
would
it
it be
because,
negative?
Because it ends up lower than it started, and we made up positive.
is it because our velocity initial should be negative? No, that
No,
doesn't
it's
make
being
any
thrown up in
sense.
the air.
It should be absolute value, yeah.
I thought distance wasn't really a, like a positive, negative, I thought it was just positive.
Yeah, but we solved for displacement.
Right. My bad.
All right.
Are you saying the whole value is wrong, or do you just think it should be negative?
We should have gotten I would have expected a negative number there. So,
Because we made up part of it.
so let me think through whether, so the fact that we got a positive means that it's, oh. Yeah, what this means is,
Hmm.
it landed above where it started.
And it just stopped.
Yeah. It was thrown from the bottom of the cliff instead of the top of the cliff.
How do you explain that? What?
Well, hang on,
Can you explain your thought process?
Well, the fact that our displacement's positive means it ends up above where it started, because we said up was positive.
OMG.
So basically what you drew wasn't accurate.
Correct.
What it actually would have done.
Yeah.
Huh, weird.
so.
That was not my plan, but that's basically the problem that I set up with the numbers I gave.
I mean, that works.
So what you're saying is in order for us to get a negative, we'd have to change the, vertical value to negative, so that it would be
Oh.
something that lands lower? Or
No, that's not the problem. If we had made down positive, then I would have expected a positive number, and we would have gotten a negative number.
Right,
So what I need to do in order to actually make this land below, because if you throw something in an arc, so the full path, I was picturing something like that. Okay, ignore those dotted lines there. Something like that. I need to make sure that the time, or the distance has to be greater than that. I picked too small a distance.
okay.
So what I'm gonna do is I'm gonna add a 0 here.
Oh. Okay, good to know.
Which makes this 7.5.
And the other one's 7.5, yeah.
And so now this becomes 7.5.
Do we need to?
Now, I
change-
do recognize that I have an advantage of using a marker on a board and not taking continuous notes or consecutive notes. But you were asking a question?
Do we need to change the sign of anything, or do we just?
Nope.
Okay.
Ooh. Still not getting a negative number.
Yeah, if you change the values, it wouldn't affect whether or not it's negative.
In theory, it seems like it would, but I got like almost 2,000 meters.
Yeah, no, that can't be right.
That makes
Wouldn't it
sense.
be that we have to use B final as 0 when we get back to the point we started at? Cause shouldn't it be that if you're going in a positive direction, your velocity is positive, but when you go in a negative, your velocity is negative, right?
Right.
You get it
So wouldn't we have to use,
174.
wouldn't we have to figure out the distance between 50 meters per second, I'm sorry, the distance from where we start to where we get to 0, and then go down to base level? Wasn't that on the quiz on Friday?
Oh, as in solve it as in 2 parts?
Yeah.
You actually can, and some students do, but that is a lot of extra work we don't have to do.
Okay.
That was so tough, but I would- another full problem. Right.
Wait,
So
I'm
what's
getting-
30 times 7.5?
Wait, I'm getting a negative
30
number.
times
Yeah.
7.5.
I got
Oh,
negative 50.6.
what?
Oh. Nice.
I
apologize.
did 300 times 7.5, cause didn't you need to change that?
Oh, no, that
Because
30
you
comes from here.
Okay,
That's exactly what I did.
that's, yeah. I saw it and I was like, why is it 30? And I changed it to 300, and yeah, I should have changed, should not have changed.
All right, so that kind of thing right there where I said how high is the cliff and it turned out it didn't actually go down, it ended up above. Occasionally that happens on a test. I can go through and I can look at a problem and go, yeah, this makes sense. And ideally I'll proof it and I won't make any careless errors. I have done proofing where I've made careless errors and ended up with a much harder problem than I expected. And so on something like that, yeah, if you notice something's off, feel free to just come up in the middle of the test or quiz and go, I'm getting this, does this make any sense? My first reaction is gonna be, no, it works. And then you'll walk back to your seat and then I'll go, oh, wait a second, and then I'll work through it and then make some comment on the board about, yeah, the problem's a little bit different than I originally intended.
I'm still getting a positive number. I'm
I
still
got-
getting 1974.375.
What did you get?
1974.375
Okay,
is the
yeah.
same as.
30 times 7.5.
Yeah, you need to do 30 times 7.5, not 300 times 7.5.
Am I
That's
still
what I-
using the same, oh, never mind. Sorry.
Yeah, I was gonna say the cliff's now 200.
If you change,
The cliff is 222 meters. I feel like we got like 5 different answers here.
Yeah.
the answer is negative 15.625.
That's fine.
That
So
is
we
what
got,
you're supposed to
you know,
get.
groundswell on negative 50.6 like when you do this.
Right.
So some of the issues might be, forgetting the minus sign here, putting 300 here. This 30 comes from the vertical velocity, or vertical component of the velocity. 7.5 seconds instead of 0.75, because that changed when I made it go 300 meters out instead of 30 meters out. So the actual answer to the question is 50.6 meters, because the question was how high is the cliff, and that is a scalar.
If we were to make a mistake on an exam and just leave it as like displacement equals negative 50, et cetera, and you were asking how high is the cliff, how much of a point doc is that? Because we've done all the work correctly, but we've just not gone back and reviewed, like, what was.
That one, is probably a point out of 10.
It's not too-
What really helps that is when I'm writing out my solution, if I make that careless error, I'm much more forgiving when students make the careless error. All right, any questions on this before I do what I consider the hardest projectile motion problem? I believe that. Numbers, this will change. meters. At 40 meters. So I give you the height and how far out it goes, and the question is, and I give you the initial speed, the question is, what is the initial angle? There are typically gonna be two answers for this. If we have a theta that, given the way I've defined it right here, a theta is positive, means I have an angle where it's being thrown up in the air. If I get a negative angle, that means it's being thrown at a downward slant.
Sorry, could you say that one more time?
All right, the last bit about the angle?
Yeah, sorry, I was just
All right,
writing.
oh, so if we get a positive angle, that means it's being thrown upwards because I've defined my angle to be in that direction. If we get a negative angle, that means it's being thrown downwards,
Okay.
which is a legitimate solution. We probably are gonna end up with 4 different angles, 2 of which do not make any physical sense.
Is I hat and J hat still the same?
Yes, would you like it to be?
Yes.
Yeah.
Okay.